Hi guys, now we are going to discuss a problem at the first given in the Codechef contest started 223, and the problem states that we will be given two arrays, A of size n and B also of size n, and we can perform following operations on the array A. This can be infinite number of operations, so each operation consists of three steps. First we choose a value for a variable x, and the second step is to find the smallest index I such that a of I is greater than or equal to x. That means we have to find an index I such that a of I is greater than or equal to x. This should be the smallest. Okay, and a third step is to increment the current indexed value by 1. That is, after selecting the value for I, we increment a of I is equal to a of I plus 1. And using these three steps, that is finding a value of x, finding smallest index I, and incrementing that value, we need to determine whether it is possible to convert the array A to array B. If so, our answer is yes. If we are not able to convert to array B in infinite number or any finite number of steps, the answer is no. Before trying to understand the solution, let's first try to understand the sample test cases, because the sample test cases is giving out a lot of information on the solution. So A is 1, 2 and 3, and B is, I'm sorry, 1, 2 and 2, and B is 1, 3 and 2. These are the two arrays that we are given in this first sample test case. Okay, if we select the value of x as 2, what could be the value of I that we select? Let me mark the indexes for you. Okay, the smallest value of I is such that the value at the ith index is greater than or equal to x is when I is at 1. That means we found a value 2 which is greater than or equal to the value x. So the smallest index it is possible for the value of I is 1. Okay, what do we do now? We increment the current indexed value by 1. So the array becomes something like this. A is equal to 1, 3 and 2, and B remains the same, 1, 3 and 2. So after performing one operation, we have converted the array A into B. So as these both are identical, the answer for this test case is yes. Okay, let's try to understand another test case that is given to us when A is equal to 1, 2 and 2 and B equals 1, 2 and 3. Let me also mark the indexes. Okay, what are the indexes where the value of A and A of I and B of I are not equal? These both are equal, these both are equal, these both are not equal. Let's try to equate them. Do some operations and increment the value of A so that we'll try to convert that into B. As the value is 2 in the position where we want to increment it, let's try to put the x value as 2 here. After selecting the value of x as 2, let's try to find the first smallest index I such that a of I is greater than or equal to 2 here. Okay, we'll start from left. 2 is less than x, 1 is less than 2, so we don't consider here. We found a value 2 here at index position 1, which satisfies our second condition in the operations list, right? Okay, so we stop here, we don't go further than that. we stop it here. But is this the index that we are trying to increment it? No, right? We are not able to reach to this position 2 with the value of x as 2. Okay, let's try to let's try to increase the value of x by 1. Let's say x is 3 here, and again we'll try to smallest index I such that a of I is greater than or equal to x. We'll check here, this is smaller than x. We'll check here, this is smaller than x. We'll check here, this is smaller than x, and we go out of bounds. So we haven't found any index for x equal to 3. So one observation that we can make from this is to increase a of I, the value of x should be less than or equal to a of I. Correct? If we try to take a value which is greater than a of I, we don't stop at that position. So always the a of I value, always the x value should be less than or equal to the value a of I if you're trying to increment the index I. Again, let's try to put some different values for x, and let's try again. X equal to 3 is failed, right? So let's try to take a value which is less than a of I. Let's say x is equal to 1. What is the smallest index I such that the second condition is satisfied? If I is equal to 0, the condition is satisfied, right? The smallest index I such that a of I is greater than or equal to x. So the I value is when the I value is 0, the condition is satisfied. So we don't go further to increment the value. At I is equal to 0, are we able to convert the last position value to 2? So with any value of x, we are not able to increment the last position value to 3. So that means for any number of operations, it is impossible to convert the value, the array elements of A to be same as array elements of B. So the answer here is no. Again, let's try the third example here to get a small edge case cleared. The third sample test case say that if the array value of A is 6 and the elements of array B is 3. Okay. From the given operations listed, is there any possible way to decrement the value of a of I to less than that value? The only operation possible is to increase the value of a of I to a of I plus a of I plus 1 and so on. That means we can only increment the value and we cannot decrement a value. But in this sample test case, we are asked to see if we are able to do some operations and decrease the value of 6 to 3, which is impossible. This is a sample, base condition, and the value, answer for this sample test case is also no. Now let's try to understand the last sample test case to get a clear understanding about the solution. The question the sample test cases is given as A is equal to 1 and 2 and B is equal to 2 and 3. Okay, we have two indexes where the values are not equal, correct? Let me mark the indexes as well. Okay, let's try to make them equal. First, let's select the value of x as 1 to increment this first number. By taking x as 1, the I will stop at 0 and we are able to increment 1. So this becomes 2, correct? Okay, this is satisfied. Now what are the other indexes where the values are not same? That is index 1. Let's try to make them equal. If we select the value of x as 2, what is the I variable at which position the I will stop. I will again stop at 0, because we found a value of x before the current position that is 1. That means we will never be able to reach to this position to increment this value as 2 3. So according to the previous observations that we made, the answer is no, right? But there's a small mistake that we made. The question never stated that we need to only increase the values from left to right. The order may differ. I mean, the order can be anything. Let's try to think in that way. Let me reset the problem. First, let's try to increment this value first. Let's say x is equal to 2, and means when I is equal to 1, it stops here, and we'll increment this to 3. Okay, this became 3. Now if we take x as 1, the I values will stop at 0, and we'll increment this as well, so this becomes 2. So now we can see there is a possible combination. I mean, there are a few operations that we can use to convert A to B. So the actual answer for this sample test case is yes. I'm sure from these 4 sample test cases, the the solution could have been already clear. But let's take another last sample test case to get a clear idea and how to get to the solution. Let's say A as 1, 4 and 2, and B as 1, 5 and 3. To solve this problem, we have to think of all the possible ways the answer is not possible. That means we have to first think what are the impossible cases in which we are unable to convert A to B. We have 2 positions at which we need to change them, right? Let's try to focus one by one. Okay, let's say we'll try to convert 2 to 3 first. Okay, if x is equal to 2, what is the first index of I will stop? Well, let me mark the indexes as well. When I is 1, will stop there, right? Because it satisfies A of 1. I mean, A of 1 is greater than or equal to 2. So this will stop. Were we able to reach the index 2 when x is equal to 2? No, right? So at any number of operations where we are unable to reach the value, the index 2 to increment this value to become 3. So what did we observe here? Whenever we need to update a value and we see a previous value which is greater than the current element here, that means as we are trying to increment to 2 to 3, correct? But we have found a value which is greater than 2 before it, then it is impossible to reach at this position, so we can never convert this to 3. In that case, the answer is obviously no. And the other edge case it is impossible is if the value of A of I is greater than B of I, that is if A is equal to 6 and B is equal to 3. In this case also the answer is no. And if these both cases haven't happened, the answer is always yes. Let's see how. Let's again take the first sample test case to prove. Okay, let's say A is equal to 1, 2 and 2, and B is equal to 1, 3 and 2. What are the indexes that cause the problem? That means we need to increment that at index 1, right? Okay. First check is A of I less than B of I? A of I is less than less than b of I, right? So there may be a possibility to convert it. So let's see. The other check that we need to do is, before this value, have we seen a value to its left? Any value that is greater than 2 or not? What are all the possible values before 2 here? The only number is 1, which is less than 2. So we are able to reach here. That means we can convert this to 3. So in this case, the answer is yes. So the pseudocode for this code looks like this. We'll declare a variable current equal to 0. This will be the initial state of current. Okay. We'll run a loop from I is equal to from 0 to n minus 1. Okay. And we'll see if a of I is greater than b of I. That means it is impossible. We return false, or I'm sorry, we'll return no. Correct? Okay. And the second check that we need to do is if a of I is definitely less b of I. If it is less than b of I, that means we need to try to do some operations to increment a of I. Correct? And what are those? And one thing that we need to check before is if a of I is less than or equal to the current value that you have previously seen. I'll see how I'll tell you how we'll update current as well. Correct? If this is so, the answer is impossible. Return no. Correct. If not, that means if none of this happens, we'll increment current as current equal to max of current and a of I. So this loop ends here, and if this return and this return does not happen, though the final answer that we get is return yes. The value current will represent the maximum value that we have seen from the current element to its left. Let's say we're at a position 3. The current variable will tell us the maximum value that we have seen the index before 3. That is from 0 to 2. What is the maximum value that we have seen? Because to increment the value at index 3, we should make sure that every value before 3 should be less than or equal to the current positions a of 3, right? So in that way, using this simple pseudocode that I have given you, we can solve this problem in order of in order of n. And the space will be order of 1. I hope you guys understood the problem and the solution. If you did, please like, share, subscribe this channel, and thank you so much.